Hello everyone, I'm Ruizhi Cheng. Today I will present our CS584 final project, Maximizing Donations Through Cost-Sensitive Learning. This is joint work with my teammates, Doan and Uddip Yalamanchili. In this project, we are faced with the problem of million donation solicitations to a population with only 5% donating. We have a dataset with 481 features and two target variables, donation status and the amount donated. The average donation is 79 cents, while the cost of a million is 68 cents. Our goal is to maximize the profit, which is the difference between the amount donated and the cost of a million. We encounter several challenges in this project and propose potential solutions. First, we need to apply a balanced resampling technique due to the significantly imbalanced dataset with only around 5% positive samples, which is the key challenge of this task. To address this issue, we plan to conduct and compare several resampling techniques such as random upsampling or downsampling and smooth. Second, given the large amount of raw unprocessed data in our dataset, it's necessary to perform proper data cleaning and pre-processing. We plan to conduct the following approaches: filling in missing values, encoding features by one-hot encoding, integer encoding, or mixed encoding, dropping relevant features, conducting feature selection and dimensionality reduction techniques, and applying normalization to improve our model's performance. Lastly, since both classification and regression approaches can be utilized in this task, we will experiment with both techniques to determine the best solution. We present our preliminary results using a classification approach with a logistic regression model without feature selection or dimensionality reduction. We propose a mixed encoding approach by combining one-shot and integer encoding approaches. The motivation is that in our experiments, one-hot is better than converting to an integer, since one-hot encoding naturally makes the data in the range from 0 to 1. However, naively, applying one-hot encoding to features with a lot of categories will significantly increase the storage and the computational overhead. Specifically, in our mixed encoding approaches, for features with less than 10 categories, we apply one-hot encoding for them. For others, we encode them to integer. After encoding, our dataset has more than 1,800 features. Finally, we normalize our data using the min-max scaler. Our results show that, without any sampling, the model only predicted negative labels, since even though its accuracy is pretty high, all other metrics, including profit, are 0. With random downsampling and upsampling, the model starts giving some positive prediction, but it's still not good enough since F1 is still fairly low. When we utilize smooth, the model predicts positive labels more precisely. Such a conclusion can be observed by comparing random downsampling and upsampling. Smooth record drops, but the precision increases. Smooth high F1 and profit can also demonstrate this point. Through this project, we learned that after sampling, a large number of features can make it difficult for the model to learn. Therefore, the feature selection or reduction approaches is necessary. We also found that sampling approaches is crucial and that F1 and precision are more correlated to profit than accuracy, since only positive labels can potentially improve our profits. For our future work, we plan to improve our model's profit by training different classification and regression models, applying various feature selection and dimensionality reduction approaches, comparing different feature encoding methods, and adjusting decision threshold for further optimization. This is the end of my presentation. Thank you for listening.